Happy Monday to everyone out there. Hopefully, the weekend has found you well and relaxed and ready to go for another week. Today, we're going to talk a little bit about properties of logs. There are four main properties, three main properties, rules, if you will, and then one change of base formula. So I'll go over these right now. The first one is the product rule. So if you are multiplying two things inside of the same control of one single log, we can split those up into two different logs or as many logs as we want. Expanding, we would be working to the more logs. Condensing, we would be working back to one single solitary log. Okay? So this would end up being log base b of u plus log base b of b. Okay? Or if we had three things that we were multiplying together, we would be able to break that up into the sum of three distinct logs. Okay? Quotient rule, now when we are dividing under the control of one log, we can subtract those two logs. And the power rule says if we have an exponent under on something that's being controlled by a log, we can simply put that exponent out in front of that particular log. Okay? So those are the three main rules. We'll get into them here in a little bit. We'll use them to expand, to expand it all the way out as far as we can go. We will also use it to contract back down into a big long list of logs, contract it back into one single solitary log. Okay? The last one is the change of base formula. This one is probably the most important one that you would want to know. Okay? And so, because not every single calculator out there has the ability to calculate logs of certain bases. Okay? A scientific calculator has the ability to calculate log base E and log base 10, but that's it. Okay? Now, some of your more advanced calculators nowadays can calculate all types of logs, but in the end, to calculate a log, okay, that's a different base. So we would have something along the lines of, this would be log base 10. And so we call, when it's log base 10, again, we don't write the 10 down there, it's just assumed. So it'd be the log of u over the log of b. Or it would be the natural log of u over the natural log of b. Okay? So we find those in those, or we can find that, we can use that to then calculate something along the lines of log base 3 of 7. What exponent would I have to put on 3 to get me 7? Okay? It's going to be somewhere above 1, but less than 2. We can not calculate that on a regular scientific calculator, but on a more advanced one we can. But we can always do that. Okay? So with those four, let's put them to work. So first off, we're going to expand. So we're going to have a single log or a single natural log, and all of those properties work for whatever log it is. So natural log, remember, is just log base E, so that would still apply. Okay? We're going to do it there, and we're going to go all the way through. We're going to get it expanded out as far as we possibly can. So I'm looking at this right in here, and I'm seeing that we are multiplying there and we're multiplying there. So then I would first write this out as log. My base is 10, so that's just going to be 100 plus log of x plus log of y to the 5th. Okay. Now I can apply the power property on this one and that one only because it has an exponent in it. I can also say, oh, well, log base 10 of 100. What exponent, when I'm thinking logs, it's always what exponent can I put on 10 to get me 100? Well, that's 2. So this one simplifies to be 2. Then log of x just stays log of x. And this one becomes 5 log of y. And that would be our final expanded statement. In this next one, I am dividing. So this would be the natural log of the top minus the natural log of the bottom. Okay. Now, in this first one, I'm actually thinking about this more mathematically. This is the quantity x plus 4 to the 1/2 power. Square roots, remember, are an exponent of 1/2. So that's how I am actually thinking about that one, because that then allows me to take that 1/2 out in front, and that becomes the natural log of x plus 4, and then minus 5 natural logs of z. One of the biggest spots for making a mistake is forgetting these parentheses here. Okay? That is all being controlled by that natural log, and I can't split those up. I could only split those up if I was multiplying them. Okay? So that's a little bit of expanding logs. Now, let's turn it around and let's condense logs. Okay? So now you don't stop until you only have one log left. When we're expanding, you're going to get multiple logs. When we're condensing, we go until there's only one log in our expression. Okay? So first here, what I would do is I would apply the power property. We seemed when we're expanding, we use the power property last. So when we're condensing, we use the power property first. Okay? So this would become log of x to the 1/2 power minus the log of y cubed. I take that number out in front and I put it back in to the exponent. Okay? 1/2 is like the square root. Subtraction is quotient. So this would just be the log of the quantity, the square root of x divided by y cubed. Make it look nice and pretty. Boy, that looks better. And I've got it down now to one single solitary log. Okay. Pause this video at any point in time or rewind it if you need to. Okay. So again, I would apply the power property, natural log of 2 minus the natural log of x minus the natural log of y cubed. Okay. Now, in my brain, I'm thinking, okay, so this 2 is going to go on top because we got a quotient here. So this would be like the natural log of 2 divided by x. But then, so now let me go over here on the side. So I've got 2 divided by x divided by y cubed. Well, that's going to be 2 divided by x times 1 over y cubed. So that y cubed is also going to end up on the bottom. So this is going to be the natural log of 2 over x, y cubed. If you need to break things out onto the side, sometimes you got to break things out onto the side and just do some maths over there. Okay? So that's condensing. Last thing we need to talk about here is change of base formula. Okay? So again, I rewrote the change of base formula up there for you. So I'm thinking, what exponent can I put on 3 to get me 8? Okay? Well, that would be something bigger than 1, something less than 2, but let's see what we got here. So if I went log of 8 divided by log of 3, now I will tell you, the biggest spot for a mistake here is on certain calculators. A lot of them in the last couple of years have been pink or they've been blue. Here is, just happened to have one. They're TI-30Xs. They're calculators that look like this. Okay? What happens is when you go to type that in, when you go to type in log of 8, let's see if I can get it. Oh, too big of a glare. Trying. Too big of a glare. But they have to close off a set of parentheses. So when you close off that parentheses first and then divide it by the log of 3 and you close off the parentheses again, then you get approximately 1.892789261. Now, 9 times out of 10, we will say, let's round that to 3 decimal places. So we would say here that this would be 1.893. We usually go out to 3. In our work, we keep it as exact as possible, but in our answers, we like to go out to 3 decimal places. Okay? And that would work also if I did natural log of 8 divided by the natural log of 3. I would get the exact same thing. Okay? Log base 4 of 16. If you didn't realize that the exponent you needed to get onto 4 to get 16 was 2, you could again do the exact same thing. You could say log base 10 of 16 divided by log of 4, or the natural log of 16 divided by the natural log of 4, and that's going to get you 2 in both cases, provided you close off parentheses after each. So after the 16, you would close a parentheses, and after the 4. Okay? That concludes expanding and contracting logs today. We'll pick up on this when we get into solving tomorrow and Wednesday. Have yourselves a great, grand, and wonderful day.